All right, hello and welcome back everyone to our live coding series where we learn how to write React applications using the 𝗖𝗵𝗶 programming language. As we saw in the previous episode, one of the strongest features of 𝗖𝗵𝗶 is that it actually allows us to get rid of runtime type errors. It actually guarantees that when we use 𝗖𝗵𝗶 to write our web applications, we are not going to run into runtime type errors such as cannot read property X of undefined, or such as undefined is not a function. In this episode, we are going to be communicating with a REST API, and we are going to see that even though we get our data from a remote server, actually, we are not going to lose this type safety, and we are going to see how we are going to achieve that in this episode. As we do in every episode, I am going to share with you the repo that we are going to be using and the tag that we are going using to code in this episode. So I am going to share with you the URL of the repo, and we are going to start from the tag EP4, which stands for episode 4. So with that being said, let's dive right in. Okay, so to communicate with an API, usually what we do in React applications is use the useEffect hook to communicate with our API, and we are going to do the same thing here when writing reason applications. So we are going to use the React.useEffect, and instead of just using useEffect, I'm going to use this nice little helper function called useEffect0, which all it does is it means that actually use this effect only on mounting. Do not use this effect multiple times. So this is just a nice helper function so that we do not need to return an empty array. Okay. So now we have inside of our useEffect function, what we are going to do is get a todos promise, right? And this promise is going to be, we're going to use the fetch module, and we are going to use the fetch function. This is exactly the same as the fetch function that you might be used to when using your React applications. So we are going to fetch the data from our local host 8080/todos. And let's save this, and we get an error, which is actually we are supposed to actually return a optionally in our useEffects, we are supposed to optionally return a cleanup function. Most people do not do this in their React applications, but it's quite important. Why? Because we want to avoid this error right here. It's called cannot perform a React state update on an unmounted component. Or there may be some other errors that can come because we are not using our cleanup function. So instead of not returning anything, for now, we are just going to return a none, which means that we are not going to return a cleanup function inside our useEffect. But as we keep coding along, we are going to actually clean up our effects and free the resources we use. Okay, so what happens here when we write this code? So this promise is actually a JavaScript promise, right? And I want to talk a little bit about this JavaScript promise because there's a small mismatch between JavaScript promise and the reason type system. And that's because of the then method that we use on promises. Let me show you why. So let's say, for example, in this comment, I will be writing JavaScript code, and I will show you why I said that there's a mismatch between the reason type system and the JavaScript promises. And it comes from the fact that you can think of the then method as being actually overloaded, so it can take different type of parameters, which is not allowed, different types of inputs, which is not allowed in reason. In reason, if a function takes, every function has a name and has a type. So when the types are different, you can't have two functions have the same name but different types. So this is what happens in JavaScript. You usually fetch your data from some remote URL, right? And then you call this .then method on it, right? And the first way we can call this then method is by calling a function that takes a result and returns a promise of some new data. One such example of this type of a function that takes a data and returns a new promise is what we usually do when we use this res.json method that comes from the fetch module. So the .json method actually returns a promise of your JSON. I think many people do not know this, but your .json method actually returns a promise of a JSON. It does not return a JSON. So you can. So this is the first way that we can use the then method, which can be as a function that takes an input and returns a promise of some output. The other way we can use the then method is doing something like this, which is taking a function that takes some input and just return some output. One such example is, for example, let's say you get an integer and you return that integer and you call the .string method on it. So what you did actually is you got an integer and returned a string, and you can think of this like, for example, like the map function from an array, right? What does the map function or the map method on arrays? It actually takes a function that changes what's inside the array and returns a new array with the new data inside of the array. So we can think of this like kind of a map of some sort. So this is the second way we can use the then method, which is a function that takes an input and returns some output. And there is a third way that people usually use also, which is when we use, for example, .then, and let's say, for example, we get some data, and what we do is dispatch some action, for example, or call set state with the data that we have. So what we did here is we used a function that takes data and returns nothing. It does not return anything. So this is the third type, or the third way of using the .then method, right? So this is what the type of the method would be. It's a function that takes an input and returns nothing, right? It just returns void. So you can think of this like the for each method, for example, on arrays, right? An array, when you use the for each method, it's a function that just you use a function that just takes data and does not return anything. It just runs some effects. It can compute something and just not return anything. So this is the third way of using the .then method in JavaScript with JavaScript promises. Okay, so let's think of or use some clear names for these usages, right? So this is first we have a function that takes an input and returns a promise. We can call it, for example, it's a then promise, right? Instead of just using then, we use the then promise, so we know what kind of input it takes. For this, it looks a lot like the map function from array, so let's just call it map. And this one looks just a lot like the argument for the for each function. So I can just call this for each. Right. So now that we have different names for different functions, we can actually proceed. So what we want to do first is actually transform this JavaScript promise into what you can think of, or what you can call as a reason promise. And we are going to do that using a library called 𝗵𝗵𝗁 that you can look online, and I'm going to show you the GitHub repo for this library. So we are going to get a reason promise out of our JavaScript promise. So now that we have our reason promise, what we can do actually is use our new reason promise. We are going to pass that to the 𝗵𝗁𝗁 promise, because we are going to use a function that takes a result. As you can see, it will just return it returns a fetch. I can type fetch.response.json on our result. So this is actually the same as what we have in here. And after that, we are not going to actually transform our data. We are just going to watch and see what is the data we get from our backend. So we are just going to run an effect. We are not going to transform our data. So we are going to use the for each function. So we're going to use 𝗵𝗁𝗁.forEach, and the function that we are going to use will be a function that takes the data that we have, and all we are going to do with this data is actually log the data that we get. Okay, so now we save this, and it's compiling just fine. And as you can see here, the compiler is telling me that everything is okay. So I can go and check my application. So now that I checked my application, I'm going to go to the console. Okay, the console. Oh, and as you can see here, we have our array of data. So what do you think the type of this data is? It definitely looks like our to-dos, right? It looks like the to-do that we want, but it is not actually a to-do. This is actually a JSON. Right? This is actually a JSON, and we do not know what the backend can return. It can return something that is that might look also like our to-do, but has some additional information, or it has some information missing. So what we need to do to keep our program safe is to actually validate the JSON and make sure that the JSON that we are getting can be actually used inside of our program. And if the data that we get from the remote backend cannot fit into our program, we will just reject it and, for example, show some error to the user, or we can do whatever treatment we need to do. So how do we validate the data that we get from our backend, right? And the fact actually is we are going to use this. We are going to use a library. It's called 𝗵𝗶𝗃𝗃 that you can look up on Google. Just write decode reason ML and you are going to find it. So we are going to use this library to actually validate the data that we get from our remote server. Okay, so the documentation here, it says that we need to have a make function. So that's what we are going to do. We are going to write a small make function that makes our to-dos. right? So we are going to write this make function. You can call it whatever you want. You just need to be consistent with your namings. So it will be a function that takes an ID, that takes a title, and it takes a completed, and returns our to-do, which is an ID, a title, and completed. So as you can see here, make is a function that takes parameters and returns a to-do. Notice again how I do not write types extensively. The compiler actually takes care of that for us, and they are actually trustable. You can trust them. Anyway, so we have our make function, and then what the library says is that we want to write a decode function. What this decode function does, it decodes the JSON. So it will take a JSON and it will use the, we are going to use this decode library to actually decode our JSON. So we need to call this succeed function with our make function. This is a bit weird, but actually I'm just following what the doc says here. So it says I need a make function. So I'm just going to follow what's in here and just change the fields and look for the fields that I need to use. So we are going to end this with a run on our JSON, and in the middle here I'm going to validate my JSON. So what I'm going to do is actually look for a field called ID, and it will be actually a number, but I need an integer from that number. What I'm going to do also is look for a field called title, and it should be a string. What I also do is take a field or look for a field called completed, and it should be a Boolean. Okay, so that's great. Now we have our decoder. And what our decoder does is it takes the JSON and it does not return a to-do, but instead it returns a result of either a to-do or an error. So if the operation completes successfully, it will return an OK data and an OK to-do that is OK to operate on and use. If it instead fails at some point, it will return an error of that with an error describing whatever happened when things failed. I just want to pull your attention and tell you that the error is not actually an exception. In reason we do not use exceptions. You can, but they are so rare and we rarely ever use them, so we don't even get to deal with exceptions. And functions usually do not return exceptions because we do not like exceptions. So now we have our decode function, and what we want to do is run a small helper function that we will call decode todos. Excuse me. And what this decode todos, it will be just actually a function that decodes a list, and it runs the decode function on the array of to-dos. So what it will does is actually take the array that we give it and run the decode function on each element inside of that array, and that's how we are going to get our list of to-dos. So let's compile this and get back where we were. So now inside of our for each function, instead of just logging the data, what we are going to do actually is decode our to-dos that we get from our data. So we can say, for example, maybe to-dos. Why I'm saying maybe to-dos? Because the operation of decoding the JSON can fail if the JSON is not what I actually want. We are going to see an example why that is important. Yeah, so we have maybe to-dos. It will be decode to-dos from the data that we have. Okay, so now what we are going to do is switch over maybe to-dos. Our maybe to-dos will either return an OK data that we can operate on. So it will either return OK to-dos, and then we can dispatch the reset action with our to-dos. Otherwise, if we get an error on some error E, what we can do is actually console that error. So it will be console.error, and we are going to use a helper function that prints the error in a nice human readable way. So we are going to use this parse error dot failure to debug string because we want to be debugging, and we give it the error, and it returns a nice message explaining what happened when we were decoding and why we have a failure. So now that our code compiles, let's check with the compiler. Everything is compiling just fine. So let's go back and check our application. And as you can see here, our application got this 𝗧𝗵𝗶, which comes from our backend, and our application still runs just fine. Okay, so let's go back to a small thing that we talked about, which was the the error of cannot call a state. Okay, what was the error? Okay, cannot perform a React state update on an unmounted component, right? So what we want to do is actually cancel our promise when our component unmounts, and we can do so easily by returning a cleanup function. And what this cleanup function will do, it will actually only just cancel our to-dos promise. The cool thing about this is that this actually works with any kinds of promises, not just let's say fetch promises or access promises. It also works with some native promises, like for example getting the permissions to use a microphone, for example, or stuff like that. So this works actually with any kinds of promises. Okay, so now let's go back to let's see what happens when the decoding fails, for example, right? So in here, let's say, for example, we are used to calling the completed state, we call it actually done. So let's say, for example, we are used to using this done field, right, to get our data, but the backend at some point changes the implementation, and for some reason they change the name done to complete it, for example, right? And as you can see here in our console, it returns an error describing exactly what happened. So it says that at position 0, I was trying to decode the field, the object, and I was looking for a field called done. It is required, but it was not present. So in this case, it's really good for debugging. Actually, you can many times find some inconsistencies between the backend and the front end, and this happens quite often when we are using just JavaScript, right? This is also good or important for performance reasons. Let's say, for example, the backend returns a huge data, for example. Instead of just returning a to-do, it returns a huge complex object, and I only need those 3 fields. what I do is get that data. I will get only the fields that I need, and all of that data that I not need will get actually collected by the garbage collector, and this way I can increase the performances of my application, which is not the case usually for JavaScript. When writing JavaScript applications, we do not pay attention to these kinds of things. So this is what happens when we have a field that changes its name. Let's see, for example, what happens when the type that I am looking for is not correct. Let's say, for example, instead of getting an integer, let's say, for example, the ID is a string, right? So right away, I get this error from the compiler that I need a string and not an integer. But let's say, for example, when actually I would just okay. So what do we do here? Okay, so what happens usually when you get a mismatch with the types, just like you saw that we got the error that tells you that the field was required but was not found. It will tell you actually that the field was found and it had, for example, the type integer, but we were looking for a string, and this is why things failed. And especially for the types of string and integer, this kind of mismatch or confusion happens quite a lot, and it can lead to some errors when using incorrect types in your JavaScript applications. So we can say that in this episode we saw how we can actually get the data from a remote REST API. We saw how we saw the difference between the promises in JavaScript and why they do not confirm and they do not match what we want from a reason perspective. We saw how and why we want to decode the JSON that we get so that we do not lose our type safety, and our application will just keep being robust just as it was before. We also saw how easy it is to cancel the promises in reason land. I hope you guys learned from this episode. I hope that you are enjoying the stream. Do not forget to leave your comments in the comment section. I would like to and would love to get your feedback and know what you guys think about the series and about everything that we are learning here. Thank you guys for checking in and being in the stream. Thank you guys, and see you. Bye.